Okay, so there are two ways to quantify the amount of radiation that is absorbed by the human tissue. The first is called the dose, and this is how much energy per mass is deposited when the radiation is absorbed. And the unit for this is the rad, and rad stands for radiation absorbed dose. The rad is equal to 0.01 joules per kilogram. The SI unit for our dose is called the gray. This is abbreviated GY. And 1 gray is equivalent to, to 1 joule per kilogram. And that is equal to 100 rads. But more commonly, we use the rad to measure dose. So rad is our more common unit. The second way to quantify the amount of radiation is called the effective dose. So this has to do with the effect of the radiation on human tissue. And different types of radiation, like alpha and beta particles. Remember beta particles, we had beta plus and beta minus. These beta particles or alpha particles do more damage than gamma rays and X-rays, even if they have the same amount of energy. So for example, alpha particles, alpha, which is a helium nucleus with 4 nucleons, 2 protons, so 2 protons, 2 neutrons. Alpha particles will do 20 times the damage of a gamma or X-ray of the same energy. 20 times the damage. And we talked about this before, how when a particle is moving through your body, if it travels more slowly, like an alpha particle does, because an alpha particle is a big particle with 4 nucleons, if it travels more slowly, it has more time to do damage in the body. So you can beta particles, on the other hand, beta particles are a lot smaller, same mass as an electron. They do about 1.5 times the damage of a gamma or X-ray of the same energy. So this takes into account something we call the relative biological effectiveness. The effective dose is equal to the dose times this relative biological effectiveness, or RDE. It has units of rem, and a rem is a radiation effective man. How effective is the radiation in harming the tissue of a person, a man or woman? And 1 rem, or the SI unit of this, is a sievert. 1 sievert is equal to 100 rem. And the important thing to understand here is that a rem of, say, alpha particles will do the same damage as a rem of gamma rays. So 1 rem of alpha particles, or alpha radiation, does the same damage to a human as 1 rem of gamma or X-rays or whatever, or beta. And the effective dose then is useful because it helps regulators to set exposure values accurately. We are all exposed to radiation in various ways, radon and in the ground and atmosphere. We just encounter radiation in different ways, cosmic rays. So when we encounter those, they're usually at very low levels, and we need to understand what our exposure values are and how those affect the human body. Because if you're exposed to excessive radiation, then you can encounter or you can have radiation sickness. There's a table in your book that lists how the type of the amounts of radiation that you'll get just due to natural or man-made things that you go about in your life, and these are usually relatively small, less than say 400 rem cumulatively throughout the year. Sorry, let me correct that actually. I thought that was wrong. It's not 400 rem, it's 400 millirem. So much less than a rem. Actually, 400 millirem would be about a half a rem or 0.4 rem. Cumulatively throughout the year, and this is due to natural and man-made exposure. So you encounter these things like cosmic rays or radioactive earth and air, or internal radioactive nuclei, just things that you consume like potassium or carbon, or radon that you inhale. These are all in a table on page 238. You don't need to know those values, but nonetheless, go there and check those out. Now, if you have one-time exposures, now this is a cumulative exposure over an entire year, but if you have a one-time exposure, for example, of 400 rem, not millirem, but rem, so 1,000 times that, will result in death 1,000 times what you cumulatively get throughout the year, and then also this is all at once. If you get 400 rem, then you're going to die in about 4 months. If you're exposed to 1,000 rem, all at once in a one-time exposure, then you will die from that in about a week. And then if you have a one-time exposure to 2,000 rem, then you'll be unconscious almost immediately with death in an hour or so. Exposure in medical procedures are usually really, really small. X-rays are 1 to 6 millirem. CT scans are 200 to 1,100 millirem.